Good afternoon, everybody. I'm running late and I haven't tweeted about this, so we'll see how robust that audience really is. So, hi, good afternoon. Welcome along to Friday. Not that it makes a great deal of difference, but it is Friday, day 10 of lockdown bioinformatics. And so, yes, the end of another week, which is, I guess, is a good thing. Right, okay, so let's get started. So yesterday, I began to talk about scripting. So the idea behind scripting, if you remember, is to provide us a means of not just running a single command, which we can do at the command line straightforwardly enough, but to run a series of commands automatically, all kind of batch together in one process. So we can run a script, and that script will run a list of commands in the order that we put them into the file in. So yesterday we wrote a very simple script which just echoed some things out to some text out to the command line. That when we run a script like that, which does some work which takes some time, even if sleeping doesn't actually take very long, it doesn't actually take very much effort on behalf of the system, but it still takes time because we're telling the system to sleep for a few seconds, that our prompt doesn't come back until that work is finished. So that's kind of the reason why I put sleep into that script. So if we just have a quick look at that script again, if you remember, we're in our week 2 directory in share, and the script that we wrote yesterday was called test.sh. So if we just use cat to look at the contents of that script, there we are, remembering that it starts with the shebang line. So that's that hash, the line which starts with the hash character, hash exclamation mark /bin/bash. That is us defining this as a bash script, a script to be executed by the bash interpreter. And then we've got 4 lines of commands, so an echo, an ls, a sleep, and another echo. And when we run that script, we've made it executable. We talked about permissions yesterday and about making files executable. So it's executable, and we execute it by pointing to its path, which is /test.sh. So this will run our script, and what you'll see as it runs is that we don't get our prompt back until it's finished running, and that's the sleep for 5 seconds in the middle of it that really means that it doesn't all run instantaneously. And what I wanted to talk about today is some more features of scripting, ways that we can make our scripts slightly more versatile. And so what I'm going to talk about today is variables, for sure. So I'm going to talk about how we define and use variables in scripts, and what variables are, in fact, as well. I'm also going to come back to something which I mentioned yesterday, which is the path. So I'm going to talk about that, and about what the path is and what it means, and about environment variables more generally, once we've done a description of variables. And I'm also going to talk about how to pass arguments into scripts. When we run commands at the command line, we can give them arguments that modify their behavior, and we can also do that with our scripts as well. There are ways in which we can pass arguments into our scripts and use that to modify their behavior between different runs, which is a very useful thing to do. So I think those are the things that, broadly speaking, we're going to cover today. First things first, let's start with variables. So Variables are a feature of any what's known as Turing complete programming language. So if you want to write if you want a programming language that is able to achieve essentially any computational task that you can pass it, then that programming language has to be what's described as Turing complete. And essentially what that means is that your programming language is capable of conditional repetition. So that is, you can have loops in your program, and those loops can take different branches depending on particular conditions. And you also need to have a readable and writable mechanism of storage. And those two features are what make a programming language Turing complete. And the second of those, having that is a storage system within your programming language for writing some information that your program needs to run, and for retrieving it later. So it's a readable and writable storage mechanism within the programming language itself. And Bash, which is what we're using here to write our scripts, is a Turing complete programming language. So it has these features. We're able to do conditional repetition, and we have a readable and writable storage mechanism within the programming language itself. And so that we're going to talk about one of those features today, and that's variables, and we'll talk about the other one next week, and that's conditional repetition. We'll talk about next week. So we'll talk about loops in Bash, and we'll also talk about conditionals in Bash next week. But today we're going to talk about variables. So variable is a way of storing some information within our program that we can retrieve during the program's execution, and it's a way of keeping track of information within your program. And all programming languages can do this. When we look at R later on, we will see that R also has a system of variables that we can use, and that it's very important to the way that programming works that you have access to these things. Variables in Bash are defined in a very particular way. We use a very particular syntax to define our variable, and a very particular syntax to retrieve those variables later. So I'm going to write a little program that shows you an example of variables in action. Okay, so first thing I'm going to do is just highlight the hash character, so I've got it in my paste buffer. There we go. Right, so we're going to write a new program, a new script. So I'm going to do nano and then the name of the file that I want to open. So I'm going to do test variables.sh. So remember, the file extension is not meaningful to the shell in any way. It's not meaningful to the command line, but it means something to us when we look at it later. Okay, so nano test underscore variables.sh. So that's opened us a new file that's ready. It's empty and it's ready to accept our input in nano. So I'm going to paste in my my hash character because I prepared myself today. There we go. Hash exclamation mark bin bash. So shebang bin bash. Instead, something I didn't mention yesterday is the hash character. Apart from on the first line where the hash character has a very specific use, you can also use it throughout your file to denote what is commonly known as a comment. So a line that begins with hash in your file, other than that first line, won't be executed by the shell. So you can type anything on that line that you want, and it won't be executed, so it won't be passed to the shell for interpretation. So you can use comments in your script files to kind of keep notes to yourself and notes about the execution of the program and what it is that you intend by the lines that you write in your program and things like that. So comments can be very useful for documenting your program for yourself when you come back later, which is a useful thing to know about. And the hash character is very commonly used to denote comments in lots and lots of different programming languages. So I just thought I'd mention that here. Okay, so variables. So actually I'm going to change that comment. This is a variable definition. So if we want to define a variable, what you do is you set the variable with a name. So we give it a name. So I'm going to call it var. And uppercase is used a lot for variable names in Bash by convention, but it's not essential that your variable name is all uppercase. But that's what I'm going to do here. So I'm going to call my variable var, and I'm going to set it equal to, and then some string. So I'm going to say, I'm going to put hello world. Okay. We're familiar with using hello world in our introductory programs, so I'm going to set my variable equal to that. So this line is something that we haven't really seen before. It's a line of Bash, so it's a line of programming, but it doesn't contain any commands. This doesn't execute any commands. This just sets a variable within our script that we can reuse later. So this isn't in and of itself doing any computation, but nevertheless it's functional and useful to us in our program. So that's the definition of a variable, and now we're going to use that variable, and to use a variable is also not too tricky. So I'm going to do another comment. Okay, this is variable use, and I'm going to use echo because it's a nice simple command, and I'm going to echo our variable. Okay, so I'm going to instead of echoing a string that we determine at the command line in the command at the time that we run it, I am instead going to echo my variable. And in order to reuse the variable that I set before, I use the $sign, okay, and then I open a curly bracket like that, and then I type the name of the variable inside the curly bracket, and then I close my my curly bracket like that, and that's me using my variable, so reusing the variable that I defined on the line above. So the important thing is when you define it, there's no $sign. It's just the name of the variable that you want to define. When you reuse it later on, you reuse it by using this dollars and the name of the variable inside this pair of curly braces. So that's the way that we reuse our variables. The curly braces here are not absolutely required. They're like single quotes around a pattern in Bash, in grep. That they're not absolutely required except in certain circumstances. But I find that it's good practice to always use them, because then when those certain circumstances crop up, you're not caught out. So you could just do $var, $var like that, but and that would work absolutely fine. But I tend to get myself into the habit of using the curly braces, because that means I don't get caught out in circumstances where the curly braces are absolutely required. So this is essentially a two-line script, although I've written it over more lines because I've spaced it out with some comments and with some white space just to make it all a bit more readable. But this is basically a two-line script in which we define a variable on this line, and then we use that variable on this line. So this will run straight away. There'll be no waiting around for this to run like there was for the previous script. We're going to save it, so Control O, write it out to that file, and then Control X to exit. So that's our script. Let's check that that it has the contents we want it to. Yes, it does. And just for good measure, although there's no reason to here, I'm just going to repeat what I was doing yesterday just to show you how to make it executable. We want it to be executable for the group because we only have permissions over the files in this directory by virtue of belonging to the VBox SF group. So I'm going to add execute permissions to the group here, and then test underscore variables. I don't need to do this in this instance because I already have these permissions, but it's just reminding us of the things that we talked about yesterday, the fact that the execute permissions are required for you to run a script, and if you don't have execute permissions, the script can't be run. So it's just making sure that we're all on the same page. And then we run it by doing / and then the name of the script, so test underscore variables.sh. So what this script should do is it should print hello world, because my variable, that's the contents of my variable, that's what my variable contains, is the string hello world. And when I echo that variable, that's what should happen. Excuse me. Excuse me a second, I'm just going to have to clear my throat. Hold on. Sorry about that. All right, okay, back now. That was interesting. Right, okay, so let's run this script and see if what happens conforms to our predictions. So off we go. Make sure I've got the right thing's got focus. There we go. There. So what happened is what I predicted would happen. Okay, so this the script runs and it echoes the words "Hello World," which is the contents of our var variable, which is kind of what I predicted would happen, and that's because this is a relatively simple script. But that's so we've defined the variable and we've just echoed it back to ourselves. So superficially, this doesn't look like a step forward on what we were doing yesterday. It's just an extra line of code to achieve the same thing. But variables can be very useful in lots of situations. So they're useful to save yourself typing in an instance where you're using a particular sort of phrase in your script over and over and over again. So they're useful in that circumstance. They're also useful if the thing that you're setting is genuinely variable, and we'll come back to that when we talk about loops next week. We also need to know about variables because there's some other things that I want to talk about which use variables, and the other things which I'm going to talk about today rely on variables for their operation. Okay, so just another couple of examples before we move on. So I'm gonna edit my test variables script again, just to add a couple more things in. So I'm going to set another variable. This time, rather than being a string, I'm going to set a number. So I'm going to set a variable called sleep. And I'm going to set it to a number. I'm just going to set it to 5. Okay. And then I'm going to put in a sleep command. But rather than doing sleep 5, which is what I did yesterday in our script, I'm going to do sleep for the length of the variable sleep. So in this case, this will sleep for 5 seconds. But it's again just showing an example of where how we can use variables in different ways. And then finally, I'm going to after the sleep, just to make sure that we know that we've reached the end of our script. I'm going to again do echo $var. I'm not going to do anything more complicated than that at this point. So now I'm just looking at the comments. Sorry, I'm just distracting myself by looking at the comments. The first thing that springs to mind is whether there's a space between the hash, between the shebang and the bin bash, which I think breaks things. Sorry, I was just slipped into Vim there. Because I think if you put a space in, it doesn't work, I think. Oh no, it does work. Okay, I take that back. So that's not the reason why the people's scripts aren't working. If you type which bash at your shell, it should return bin bash. If it returns something different, then that's what you need to put on your shebang line. So if which bash returned user env bash or something like that, then that's what you would have to put at your command line, in your shebang line, not bin bash. So I'm just trying to think of reasons that might why this might not work. Path shouldn't affect it. Okay, anyway, I'm going to hope that Peter can solve that and keep going. And apologies if I'm leaving anyone behind. Okay, delete that space. So okay, so in the process of doing that, I ran this script, okay, so we've got two variables this time. We've got our variable var and our variable sleep. We're using those two things in an echo, and then as the name of the variable suggests, a sleep, and then another echo. And if you were watching while I ran it before, then yes, save. Then you will have seen that the variables again worked as expected. So the script echoes hello world, then sleeps. Excuse me, and then echoes hello world again after that sleep for 5 seconds. So again, the variables are working as we expect. It's showing you that you can pass pass a variable as a number as well as a string. So you don't have to give it some words in a string of text. You can also give it a number, and it will be interpreted in the right way by Bash. So these are useful things. What I want to move on to talk about now is some different types of variable that are important to the system, our Linux system, which we haven't really talked about yet because we haven't, up until now, we haven't known what a variable is. So there are some variables so we've been setting user variables in scripts. So variables that we define, we know the names of the variables, and those are useful within our scripts in various ways that we will come to over the next few lessons. But the system also sets some variables for us. And the variables that are set by the system are set at the time, they're set when you log in, and they're used by the system in all sorts of ways. And I wanted to talk about those variables a bit now. And these are called environment variables. So they're particular types of variables that are useful to the system in various ways. And so environment variables are used for lots of different things. One of them is the path that I'll come to in a minute, that is useful to the system in various ways. But I'm going to talk about a couple of others first. So one of which is home, $home. Okay, so you can see the contents of a variable in the same way as we did in our script. So if you remember, excuse me, in our script, which I will cat to the screen again, we could see the contents of our variable by echoing that variable. So echo and then the name of the variable prints out the contents of that variable to us, to our standard output. And we can use that at the command line to have a look at some of these environment variables. So there are lots of them. They're named the same on all Linux systems, and they're usable within scripts as well as at the command line. But we can have a look at some of them. So, for instance, one of these environment variables is the home variable, and we can look at that by echoing it in the same way as we echoed our var variable in the we can echo our var variable in our script. We can echo our home variable at the command line in exactly the same way. And so that's what I'm doing here. Just echo dollars, open curly brace, home, close curly brace. And then off we go. And that echoes, as we might expect, given the name of the variable, that echoes my home directory. Okay. Now, I know that we know what our home directory is, but this can be useful in certain ways. It can also be useful to make scripts that we can move between different systems where our home directory might be located in different places. So one example of this that's admittedly specific to Newcastle, but may be true in other places as well, is our HPC system is set up in a particular way. Such that our home directories are not /home/username, they live somewhere else on the system. And so knowing what your home directory is by virtue of accessing this environment variable can be quite useful. What I would just an aside towards the comments again. What I would say is if the script that you've written today isn't working and the script that you wrote yesterday is working, then copy and modify the script that you wrote yesterday. So instead of writing a whole new script from scratch, use CP to make a copy of yesterday's script and then edit that script to look like today's script, and maybe that will eliminate whatever the hidden problem is in today's script, which has cropped up for reasons that we can't necessarily figure out. That might be one way to try and debug it. Right, okay, to pick up back again where I was. So, environment variables. So this is one useful environment variable, the home environment variable. There is also one which is your present working directory. So $pwd always contains your present working directory. So if I echo this, it's like running the command print working directory. It's the same, gives me the same output. And actually, if I change directory, so if I cd one level up and then echo pwd again, it will have changed. It keeps a record of where you are in the system. That's another one which might be quite useful. And then the one that I really want to talk about is the path environment variable, which sorry, I've just echoed rather than CD. I've got into habits because I'm typing echo over and over again. Right, okay, back in week 2 now. Path. So echo dollars path. So by convention, a lot of these variables will usually be in uppercase. Again, it's convention, it's not required, but variables will often be in uppercase in Bash particularly. So I'm going to echo the path, and then I'm going to talk about what the path is. Okay, so there you go. That's my path on my VM. And this is a list of directories separated by colons. So you've got user local sbin colon user local bin colon user sbin, etc. And this is a list of directories on the system, and it's a list of very particular directories. These are directories where the system expects to find executable files. Okay, so what happens when you type the name of a command? It may not actually necessarily be what you expect would happen. So when you type ls, for instance, what you're actually telling Bash to do here is to go and look for an executable with the name ls somewhere in your path. So somewhere in this string of directories which is defined in your path. Okay. So what happens when you run this command is is the shell bash goes into each of the directories in your path in turn and looks for an executable called ls. So the first thing it will do is it will go into user local sbin and look for an executable called ls. And if it doesn't find one in there, then it will go into user local bin and look in there for an executable called ls. And if it doesn't find one in there, then it will go into user sbin, and so on, until it finds the executable called ls. If it gets to the end of your path and it hasn't found the executable that you've asked for, that's the point at which it will say command not found. That it will report the fact that it doesn't find a command on the system called ls, because it's looked in all of the places where it thinks it might live, and that is all of the places on your path, and it hasn't found that executable. And the other thing that will happen, the other thing that's important to note here, is that if there is more than one executable in your path with the same name, so if there was another ls in my path somewhere, the shell would execute the one it finds first. So it goes through these directories in order, and as soon as it finds an executable of the right name, it runs that executable and it stops looking. So it only goes as far as the first entry. So if I had an executable in user local bin called ls and an executable in /bin called ls, it would run the one in user local bin because that's the first one it would find, and it would never get to the one in /bin, and that one would never be run. So that's another important thing to note. So when I run ls, the shell goes and looks in user local sbin, user local bin, user sbin, user bin, sbin, bin, etc. until it finds an executable called ls. If you want to know where that executable lives on the file system, there's a command called which, and which will tell you for a given command, which will tell you where it finds that command on your path. Okay, so which ls will tell me where on my file system, where in my path ls lives. Okay, and we can see that ls lives in /bin. So /bin/ls is where that command is. So it has to get all the way through to bin in the path before it finds ls to execute, which is fine. It doesn't take it very long to do that. If we make a typo and we type the name of a command that doesn't exist, so ld does exist, I'm just looking at the letters around S. LA is usually an alias. How about LX? I don't think LX is a command that exists. So if we mistype and we type the name of a command that doesn't exist, so the shell doesn't try to correct you. Bash doesn't try to say, oh, perhaps you meant ls. There are shells, so we use bash. There's a shell called Z shell. Z shell will try to correct you. It'll say, oh, maybe you meant ls, and it will ask, and you can tell it that you actually, yes, you did mean ls. But bash isn't that clever. Bash just looks for the command called lx and can't find it anywhere. So there isn't a command called lx in our path anywhere. So in none of those directories that are listed in our path can we find the lx executable. It's because it doesn't exist, because what we were actually meant to type was ls. Okay, so that's your command not found. So the thing that I wanted to come round to was talking about scripts and whether it's sensible to get scripts in run. So we'll get command not found. Sorry, test variant, let's get the name right at least. We'll get command not found because that script isn't anywhere in our path. It's not in any of those directories that are in our path. So there are two ways that we can run this script. There's the way that we've been doing it, which is giving a path, giving the shell a path to the script, telling it which directory it lives in. And you can do that just with // and that's effectively kind of dynamically adding that directory to your path for that one command. The alternative is we can add the directory that our script is in to our path in a slightly more permanent way. So you can do this by resetting the path variable. If we just echo path again, we can see what it contains. We can expand our path by resetting it, and we set variables at the command line in the same way as you set them in a script. So name of the variable, then an equal sign with no spaces. It's very important that you don't have any spaces. And then we're going to add our present working directory to our path, and I'm actually going to do that with a variable. So $pwd, because that's where our script lives. And then if you look at the way that the path is defined by the system, it's a list of directories that are separated by colons. So if we want to add an extra directory to this, we have to add a colon to separate our new directory from our existing list of directories. And then we need to add in the existing list of directories that are in the path. And we do that by redefining, by re-specifying the path here. Path equals our present working directory, colon, and then our current path. And this will add the present working directory to the beginning of our path. So the very first thing in the path will be our present working directory. So if we run this command, and then if we echo our path back to ourselves, you'll see it's the same as before. We've got user local sbin, user local bin, etc., the same as we did before. But at the beginning of our path, we now have our present working directory that we've added on. Okay, so we've added that onto our path. And now, if we type test underscore variables .sh, our script will run because that script is now in our path. So when you run this command, the shell goes and looks in the first directory in the path, which is at the moment is our present working directory, and it finds test variables in that directory. There we are. So we are now able to run that command without having to do the / or define a path to it at all, because that command, that shell script, is now in our path. And as a result of that as well, we can use tab completion to complete the name of the command. So if I type test underscore and then press tab, actually what the shell is doing when you press tab is it's looking in your path for anything which meets the string that you've started to type. So it will find our shell script in that case, and again we can run it and it will run because it's in the path. This modification of the path, by the way, only lasts as long as I have this terminal open. If I close this terminal, so if I close the terminal, so if I type exit, and the terminal will close, and then I reopen the terminal, my path will be reset. So that directory that I've added to the path will now be gone. So I've reopened a new terminal. I've not logged out or restarted the computer or anything like that. I've just closed the terminal and opened a new one, and my path will have been reset to the system default. So the share a new session. So all of the settings from your previous session are all gone. You're back in your home directory. You're not in the working directory you were in before. And any adjustments that you've made to your environment variables have been reset to the defaults. If you want to see your whole environment, if you want to see all of your environment variables, there's a command which is printenv, and that will print out all of the environment variables currently set in your session. Some of these will make sense and some of them won't. Some of them make sense to me and some of them really don't make sense to me. So there's a shell environment variable that tells you what your current shell is. You can see the path here as well. That's one of the things that we've managed to set. That is set by the system when we log in. But there's a whole bunch of other things here which may make less sense to you as a fairly naive Linux user. But actually, there's a whole load of things on here which don't make a great deal of sense to me as quite an experienced Linux user. Sorry, I lost my train of thought there. Seems to be happening a lot today. Okay, so that's our environment variables, and they're useful in lots of ways, and we can use those in scripts as well. So for instance, you can use your home variable in scripts, and you can use your I think there's a, although I haven't spotted it in this list, but I'm pretty sure there's a environment variable which is user. Yeah, there is, which can be useful as well. You can use that in scripts in various ways sometimes if you need to as well. So that's environment variables, and specifically the path, which I wanted to talk about. So the final thing that I want to talk about this afternoon and this week is arguments, passing arguments to scripts that we write. Okay, so it is possible to send your script an argument and have that argument as a variable inside your script. So there are special variables within scripts that reference the arguments that you pass to them. And again, I'll show you what I mean here by example. Okay, so let's. What I'm going to do is I'm going to copy my test. Oh no, I'm not in the right directory. Sorry, I'm in home directory. CD share week 2 list. Okay, and then I'm going to copy test variables just to save me a bunch of typing to test underscore arguments.sh. Okay, so I'm just going to take a copy of my script. So there we go. And then I'm going to edit my new script. Right, so there is a special set of special variables inside scripts that refer to the arguments you pass the script, and they are variables that are defined by numbers, so $1, $2, and so forth. So I'm just going to I'm going to cut and then undo. Right, I'm just going to add an extra line, and I'm going to show you some of these variables. So instead of echoing $var, I'm going to echo $0. So this is a special variable that refers to an argument that we pass to the script. And actually $0 is a special variable that actually refers to the name of the script that you're running. So this is actually the first argument for the script, and that is the script itself. And then any subsequent arguments, so anything else that you put at the command line after spaces, on is the next argument that you pass your script. So I'll show you how this works by running this script with one argument. Okay, so I'm going to save by doing Control O, and then I'm going to exit. I know that my script is already executable because of where I am on the system. Because I'm in the share directory, the script is executable as soon as I create it because of the special permissions that these files get in this directory. So I'm just going to run it. If you're on a different system where your scripts don't get these permissions by default, then remember chmod user plus execute name of your script, test arguments. We'll add execute permissions for the user so that you can execute your script. /test arguments. And then I'm going to give this an argument. So in order to pass an argument to a script, you run the script, then you have a space, and then any argument that you want comes after the space. So I'm just going to have an argument which is arg1. If you want to have a space in your argument, so if we wanted to pass this hello world, for instance, then we would need to have quotes so that the space in the argument isn't interpreted. But I'm not going to have a space in it, so I'm just going to do arg1. So when I run this script, and this happens whenever you run a script, whether you use these variables or not, when I run this script, the variable $0 will be set to the name of the script, and the variable $1 will be set to the first argument which I pass to that script. So you'll see the results of this when I run it, in that I will echo $0 and then $1, and then I'll sleep for 5 seconds, and then I'll echo hello world, which is $var. Okay, so off we go. So there you go. You see it echoes the name of the script. That's the thing that you've run complete with the /, and then it echoes the argument that I've passed it, and then it echoes hello world. And what passing the argument into this script means that I can do is I can change the behavior of the script without changing the script. So if I want to echo something else, I just change the argument. So if we rerun this, but we give it a different argument, so let's give it the name of my cat. There you go. This time, the behavior of the script changes, even though I've not even opened the script in Nano in between running it the first time and running it the second time. All I've done is change the argument. And changing that argument is enough to change the behavior of the script. So being able to pass arguments into your scripts can be a really useful thing to do in terms of making your script sort of configurable and usable. And we'll come back to this again when we start to write more complicated scripts next week. So just a couple of other things. I'm going to edit my script again. Just a couple of other things before we finish, okay? So we've looked at $0 and $1. I'm going to make this sleep for $2, okay? Which is, so I'm telling it to go to sleep for the length of time defined by an argument. And I also want to do one other thing, and that is I want to echo a couple of special variables. So the first one is, get the right character, there we go. The number of arguments is, so there's a special variable, this is a bit weird, but it's $hash that contains the number of arguments, so that the value of $hash is set to the number of arguments that you have to do is the list of arguments is $at. Okay, so $at is another special variable that gives you a list of all of the arguments for your script. This can be very useful if you want to start looping over those arguments, and we'll look at that again. We'll come back to that again next week. Okay, so that is my new script. I've changed it quite a lot. I'm just going to exit. So I save it, Control O, and then exit. Then I'm going to just cat the script so it's still on the screen for people. So I realise I've gone quite quickly there. And then I'm going to run this script. And I'm going to run it with 2 arguments. Okay, so test arguments. The first argument is the thing that I want to print in my echo $1 line. So that is, let's say, here we go, disco chick. Okay. And then the second is the amount of time I want it to sleep for. So I'm going to sleep for 5 seconds. And then we're going to run. If I put something other than a number there, sleep would probably fail. But I'm not doing any kind of special checking that these arguments conform to particular things. I've done nothing to check that second argument is a number, so my script will fail if it isn't. But there are things that you can do to do that. Right, okay, so there you go. So it echoes my first argument, then it waits for the length of time for my second argument, and then it tells me how many arguments there are, not including the name of the script, so that's 2 arguments, and it gives me a list of those 2 arguments. Okay. But it doesn't enclose them in quotes in the same way I did, so that actually looks like 3 arguments, and then it echoes my variable var back to me as well. Okay, so that is my my new script as it is. If I want it to go to sleep for longer, then I can change that to be 10 seconds, and now it will sleep for a variable amount of time, and I can change that amount of time by passing in a new argument, a different argument, and it will sleep for longer. So, okay, that's arguments and variables and environment variables, and that's everything that we're covering today. So hopefully that makes some sense. There's again, we've covered quite a lot of ground, but it's all ground that we will cover again next week. So we will come back to all of these things next week when we're writing slightly more complicated scripts. So my aim for the early part of next week is to write, is to teach you about loops, so about for loops. And I might do conditionals as well. But then we're going to put all of that together to write a script that will download some data from somewhere. So we're not yet going to download our sequencing data. That may come towards the end of next week, or maybe early the week after. So we're not going to we're not yet going to be downloading that data, but we're gonna write a script next week that does download some data, and I'm getting to the end, and you will have realised that I've had no Jacob's picture of the day, and that's because we've had a bit of a distracted day today, and I haven't been able to get a time for him to draw one. So unfortunately, we don't have a picture of the day. Get rid of that. And then open that and do that. There you go. Make it bigger. There you go, Disco Chick, just for nostalgia's sake. So there we are. Just because I couldn't get him to draw a new picture today, so we will stick with an old classic, even though it was only yesterday. Okay, so that's all from me for this week. Thanks again to those that have tuned in, and it's nice to see that even without me pushing it on Twitter today, we've got I think pretty much the same core group of people tuning in to follow along live, and I know there's also a group of you who follow along the next day as well, so it's really good to see that we've kind of got a fairly core group of users who are coming back every day, which is really nice to see. So that's it from me for this week. Although I am technically on annual leave on my job next week, I will be here at 4 p.m. Certainly for the first 4 days next week. I don't think I'll be doing Good Friday or Easter Monday. So I think we'll have 2 4-day weeks, but I will be here Monday through Thursday next week, 4 p.m. UK time, so 4 p.m. BST. So I will see you next week. Have a lovely and restful weekend. I hear in the UK that the weather's going to be quite nice this weekend, so try and get outdoors in the garden if you can, if you've got a garden. Try and get some fresh air. Have some rest, and I will see you all next week. Stay safe, keep well. See you next week. Bye, everybody.